Chemistry in medicine. This branch goes even further from where you think, because it's present in every human process, such as life, growth, and death. It's important to mention that living species like the man are composed by cells whose cytoplasm, from the chemical point of view, is part of the chemical elements, such as carbon, potassium, hydrogen, calcium, sulfur, oxygen, sodium, phosphorus, nitrogen, and magnesium. It's very interesting to know how our organism is composed in a chemical way, and how everything is intensively related to start up this complex machine called human body. So, to understand the relationship between chemistry and medicine, it's necessary for you to know the basis of organic chemistry. One of the things that can be done with this science is the creation of antiseptics and disinfecting products that allow surgical interventions. Now, this plays a very important role in medicine. Why? Because it contains substances that produce the desired effect that you wanted in your organism. That's why the chemical industry has built up the relationship between technology and chemistry. How? By creating artifacts like syringes, transplants, petri plates, microscopes, capsules, laser surgery, and many more. So, thanks to all of this and more, we can make our living easier and reach older ages. Obviously, as long as we maintain ourselves healthy. But it's important to know that science and chemistry is not always perfect and right. What do I mean by this? Well, as you know, medicines may cause side effects in your organism. That's why it's important for you to not automedicate yourself. Follow your doctor's prescription step by step. So, what can we infer and conclude about all this? Well, we can say that the relationship between medicine and chemistry is very fundamental. Without chemistry's help, medicine wouldn't have made all these interesting developments. We will still be in those centuries where they had painful surgeries and homemade medicines. Therefore, the importance of chemistry in medicine.
Food chemistry is the study of chemical processes and interactions of all biological and non-biological components of food. The biological substances include such items as meat, poultry, lettuce, beer, and milk as examples. It is similar to biochemistry in its main components such as carbohydrates, lipids, and protein, but it also includes areas such as water, vitamins, minerals, enzymes, food additives, flavors, and colors. This discipline also encompasses how products exchange under certain food processing techniques and ways either to enhance or to prevent them from happening. An example of enhancing a process would be to encourage fermentation of dairy products with microorganisms that convert lactose to lactic acid. An example of preventing a process would be stopping the browning of the surface of freshly cut red delicious apples using lemon juice or other acidulated water.
The chemistry and the war. The First World War, also known as the Great War, was fought from late July to November. It made the armies and industry of the Central Powers, notably German, against two of Britain, France, and other alliance powers. The industrial scale death and destruction to the world would not have been possible without the industrial scale production of a vast variety of chemical substances. Most important, exclusively for shell bombs, grenades, chemical warfare agents commonly known as poison gases, metals and nylons for making weapons, and ammunition. Some of the chemical warfare in the World War Number One was the two gases chlorine, phosgen, and mustard gas. The care of the second one and the protection of drops and soldiers also relied on chemical materials. Chemicals for gas masks, metal for making armor and steel helmets, dyes for military uniforms. One of the chemical substances employed in the war was the chlorine, strychnine, acid, phosphorus, and ammonium.
Ya. No, seguro. A ver, ¿cómo se escucha?
Chemistry and global warming.
Global warming change is a very complex subject. All of Earth's spheres, the biosphere, hydrosphere, lithosphere, and atmosphere work together to create and maintain climate. However, the biosphere, humans in particular, has had an increasingly greater impact on climate in recent decades.
One way in which humans have affected the climate is by increasing emission of greenhouse gas. Greenhouse gases absorb infrared long-wave heat radiation. This is a form of the sun energy reflect off the Earth's surface. Greenhouse gases then radiate heat energy back toward the Earth. This heats the Earth's atmosphere and ultimately contributes to increasingly warmer climates, a process known as global warming. Common greenhouse gases include carbon dioxide. Carbon dioxide is a byproduct of the combustion or burning of fossil fuels, such as coal and oil. Since the Industrial Revolution, humans have burned increasingly greater amounts of fossil fuels for energy. This energy has been used to heat homes, operate automobiles, and power industry. As the practice of burning fossil fuels grows, so does the amount of carbon dioxide emitted to the atmosphere. During the process of combustion, O2 reacts with glucose to produce water and CO. As the organic matter burns, chemical energy in the form of heat and light is released. The following chemical equation describes the chemical process of combustion.